Hello guys, welcome to my channel. Now we are going to solve about triaxial deformation. So this is basically a problem number 223 on the strength of materials book. So the problem states a rectangular steel block is 3 inches long in the x direction, 2 inches long in the y direction, and 4 inches long in the z direction. The block is subjected to a triaxial loading of 3 uniformly distributed forces as follows. 48 kips tension in the x direction, 60 kips compression in the y direction, and 54 kips tension in the z direction. If V or the Poisson's ratio is equal to 0.30 and E or the modulus of elasticity is equal to 29 times 10 raised to 6 psi, determine the single uniformly distributed load in the x direction that would produce the same deformation in the y direction as the original loading. Okay, so here it is guys. So these are basically the givens. So these are the lengths for the x direction, y direction, z direction, and these are the loads, the letter P. So this V guys is the Poisson's ratio 0.30 and our modulus of elasticity is 29 times 10 raised to 6 psi. So let's move to the solution. So first, for triaxial deformation or tensile triaxial stresses, we indicate that our tensile stresses or tensile forces are positive and our compressive stresses or forces are negative. So let's write first our formula. We have here y is equal to 1 over E multiplied to stress y minus Poisson's ratio multiplied to stress in x direction plus stress in z direction. So this is our formula guys for getting the strain in y. So in the formula we have here stresses in y direction, stresses in x direction, and stresses in z direction. So to satisfy this formula, we should first get these stresses guys, so that we can put the stresses here. We can use this formula. Okay, let's go first for stress in x direction. So as we all know, the formula of stress guys is equal to P over A, force over area, Px, or and here in the A we have here Yz. For our force, our loading in the x direction, we have here 48 over, for our area guys, in y we have here 2 inches and our z is 4, so we put here 2 times 4. It is because guys our figure is a box, so the formula of getting the area of a square is length times width, right? So for me, what I put into my mind is, for example, if I look for the stress in x, so I will put here force in x over area on the other axis, guys. So like here I have X, and then for the area I will base my area on the Y and Z axis. So I hope you get my point, guys. So here, let's solve this. 48 over 2 times 4. Our answer would be 6.0 KSI. And tension. This is tension, guys, because here in the given, in the X direction, we have a loading of 48 kips tension. So the answer here is also tension, since it is positive. So next, let's move to stress in Y. Okay, stress in Y is equals to Py over area. So since we have here Y, the remaining axes, guys, are X and Z. So I'm gonna put here X and Z. This is what I mean, guys. I hope you can get my point. So this thing or this key helped me to solve problems, so that I will not be confused on getting the area, guys. So for our force P, we have 60 kips. Force in Y direction, 60 over, so area and XZ. So we have X 3 times 4. Okay, 3 times 4. So the answer would be 5.0 KSI and compression. That is compression, guys, because here in the given 60 kips, it is compression. Is compressive force. So let's move to the stress in Z. So again, we have the formula of P over A. Let's indicate here. So PZ, and here our area is, we are going to put XY. Okay, over okay, guys. So for our force P, we have here 54 over area X times Y. So X 3 times Y 2, 3 times 2. Okay, so the result would be 9.0 PSI. And this is, since this is tension and it is positive, guys, we put here tension. Okay, now we already have these stresses. Now we can use these stresses in this formula. Here, guys. So let's input these stresses in the formula. Okay, so I'm gonna rewrite it. Our modulus of elasticity, guys, is 29 times 10 raised to 6. Multiplied to stress Y, or stress in Y is this. So guys, since looking at the formula, since this is PSI, our modulus of elasticity is PSI. Here PSI, and our stresses are PSI, KSI. We are going to convert these stresses or these units into PSI. So this would be, this 5 KSI would be 5,000 PSI minus the Poisson's ratio 0.30 multiplied to stress in X 6,000 psi plus stress in Z here 9,000 psi. Okay. So we have satisfied I mean our formula, guys. And now what we are going to do is just input this into our calculator and solve for this. So the result would be, okay guys, by the way, I forgot. So we know that our tensile stress, our stress in y direction is compressive, guys. And as I said earlier, let's indicate our compression as negative and our tensile stress as positive. So basically here in this 5,000 psi, let's indicate this as negative. And our tensile stresses are going to be positive. So here, guys, they are positive. Okay. And now let's solve this, guys. So the answer here is negative 3.276 times 10 is to negative 4. Okay. So now this is our deformation. Wait. Or strain in y. Now we already have our strain in y. And let's move to the uniaxial formula, which is I'm gonna write the continuation of my solution, guys, here. Okay. The formula on our uniaxial formula is, or uniaxial stress or deformation, uniaxial deformation I mean, would be B is equal to EY over strain in X. So I'll indicate this, guys, as uniaxial. Okay. Now let's manipulate this formula, guys. Since we have this value, guys, this strain in y, this we already have this. Now let's manipulate this and let's turn this into negative V strain in X is equal to strain in Y. What I did, guys, is that I divided this negative 1 over strain in X here in V, and then the EX, I moved it to the top, guys, so it became negative V EX. Okay. So now here, based on the Hooke's law, we can replace this EX here, guys, since we do not have any value here. We do not have any given this EX. What in this formula, we only have this V, which is 0.30, and this strain in Y, which is this. So negative V, we can replace this EX by what, guys? By what? Based on the Hooke's law. can replace this by stress over modulus of elasticity. Okay, so I'll indicate this as x. Stress in x over modulus of elasticity equals to strain in y. Okay, now here we have now three givens here in this equation. We have Poisson's ratio, strain in y direction, and modulus of elasticity. Now what we are looking for is what is the value of this stress in x direction. So again guys, let's manipulate this formula. Let's derive it. So this is going to be stress x is equal to negative strain in y times modulus of elasticity over b, Poisson's ratio. Okay. Now let's put our givens here guys, here in the equation. Okay, so here we have negative strain in y. So our strain in y would be this negative 3.276 times 10 raised to negative 4 multiplied to modulus of elasticity, which is here 29 times 10 raised to 6. Okay. Raised to 6 over Poisson's ratio, which is 0.30. Now, let's solve this guys. Let's solve this in the calculator. Okay. Simply negative 3.276 times 10 is to negative 4. 9 times 10 raised to 6 and 0.30. So the answer is 31668. 31,668. 668 PSI guys. PSI. Okay, now we already have stress in X. And what we want to know guys, basically in this problem, is the force in the x direction. What should be our force in the x direction guys? What should be our load in the x direction that would produce the same deformation in the y direction? So based in this formula guys, based on this stress formula, we can have force in the x direction because we already have this stress in the x direction guys, and obviously we have a given of area. Okay, So stress in X, here 31,668 SI, Px over area YZ, okay, YZ here, 2 times 4, okay, times 4, okay. Multiply this, guys, and then we can get this P. Px now would be 253,344 pounds. And this is tension. So the unit, guys, here is pound, because here we have PSI, pound per inch squared, and here in the area, the result of this would be inches squared. So once you multiply inches squared to pound per inch squared, the inch squared, guys, will be cancelled. So the remaining unit would be pound. Okay, gets? And then because this number is so big, we can convert it into smaller, guys. But here it is already, this answer is already correct, but let's convert this into kips. So this is equal to pound. Let's convert this to kips. We have 253.344 kips. Then tension. So this is now our final answer, guys. We need 253.344 kips force in the box, guys, in the X direction, so that we will be producing the same deformation in the Y direction as the original loading. So, guys, thank you for watching, and honestly, guys, I am doing this, or I am making this channel so that in my part I am reviewing myself, and basically I can also share my knowledge to you guys. So because, guys, they said that you will learn more if you teach, guys. If you teach your knowledge to others, you will learn more, you will retain your knowledge more, you will not easily forget. So I am open for any improvements, guys, any correction, because I want to improve my solving skills, guys. And thank you for watching again, and see you on the next video. Bye bye.